In the second lesson on relationships, we are going to look at lines of best fit. In this lesson, we are going to draw scatter plots and determine if a line of best fit is appropriate, and then we are going to make predictions using the line of best fit. So to start off with, I've given an example of a scatter graph, and we can see that there is a downward trend. So there's a decreasing relationship here. And we can see that this is the hours of exercise per week and resting heart rate. So as the hours of exercise per week increases, the resting heart rate decreases. Because there is a relationship here, we are able to draw a line of best fits. And then that line of best fit will help us make predictions. There's two types of predictions. The first is called interpolation. This is when our prediction is inside the data collected. So in this example above, if I want to predict the resting heart rate when someone exercises 5 hours per week, I can just go up to the line and then go across and realize that it's about 60 beats per minute for 5 hours of exercise per week. 5 is inside the data collected. The data started at 0 hours per week and went up to 9 hours per week. So this is interpolation. The second type of prediction is extrapolation. And this would happen if I wanted to make a prediction that's outside the data collected. So for instance, if I wanted to find the resting heart rate for 10 hours of exercise per week. You can see, so this is extrapolation because I would have to extend the line to see what the resting heart rate would be for 10 hours of exercise per week. And this is less reliable because it lies outside of the data collected, whereas 5, which was interpolation, was more reliable because it's inside the data collected. We will continue to talk about this in our further examples. So here are two checklists for you to check when you're creating a graph. The first one is to make sure your scatter plot has everything it should have in it. Did you write labels on your axes? Did you determine the appropriate scales? And did you plot the points accurately? The most difficult one is determining the scales and making sure that the increase in your scale is consistently the same. On the right, there's a checklist for drawing the line of best fit. Just get rid of part of this. Just get rid of that part here. Here, you want to use a plastic ruler if at all possible. If not, you're going to want to turn your ruler on the side to draw the line. Did you draw your line through as many points as possible? Did your line follow the direction of the points? Did you try to get about the same number of points above and below your line that you drew? And did you use more than just the beginning and the end points? So once you've drawn a line of best fit, just go through this checklist to make sure it's the best possible line that you could have drawn. In our first example, we have a scatter plot drawn for us. This scatter plot shows the relationship between shoe size and the height of a person. There are points plotted for us, and 4 of these points are labeled for us. If you notice our scale, our shoe size goes up by 1s, and it consistently goes up by 1. The height goes up by 5s, so it doesn't have to be the same scale as our y-axis. Also, we notice that it does not start at 0. The height starts at 150. And so there's this little squiggle in the axis to say I did not start at 0. The first question asks, what is the independent variable? The independent variable is along the x-axis, which is the horizontal axis, so it is height. And B, the dependent variable, is along the y-axis, or the vertical axis, and that is shoe size. So that says shoe size is dependent on the height of a person. We are asked to draw the line of best fit in part C. So we can follow the checklist on that first page of our handout. This will be difficult for me to show here because I do not have access to a ruler or a straight line in this program. But looking on that checklist, one thing it says not to do is just join the first and the last points with a line. This does not necessarily capture the trend that is shown in this data. So what we will do, if you have access to a clear ruler, that would be the best thing to do or to use. If not, flip your ruler on your side and try to cut the points as best as possible. So there's the equal number of points on either side. Here there are 15 points, so you probably want about 7 or 8 on each side of your ruler. You also want your ruler to go up or to have a slope or rise along with the trend. So here we can see that there's an increasing trend, so our ruler should be going up. And I'm going to draw my line. Again, it's not a great line because I don't have access to a ruler in this program, but it looks something like that. So now I'm just going to check. How many points do I have on the bottom of my line? I have 7, and on the top, I have 7 as well. This point I would say is on the line. So it's good to have points on the line, but not necessary. You really want to have this line represent all of the points. That said, we see that this line is not close to 2 of our points, y and x. These points are actually outliers, meaning that they don't follow the trend of the other points. All these other points are very close to my line of best fit. These two are not, so I would call those outliers. So it's not always possible to get your line of best fit to go through and find the trend of all of your points. So now let's use our line of best fit to answer some questions. First, we just have to fix these questions. The first one says, what is the expected shoe size of someone who has a height of 170 centimeters? So on your graph, again, take your ruler, find the height of 170, which is here. Draw your ruler up to your line of best fit, and then draw over to your y-axis. And again, this should be done with a ruler. My line goes to just above 9, so I'm just going to say shoe size 9. I could say 9.5 because shoe sizes do sometimes come in half sizes. And then the question asks, is this interpolation or extrapolation? Well, the data was collected up into 180 centimeters height and as low as 150 centimeters. 170 is within the points collected, therefore it is interpolation. In E, it asks, what is the expected height of someone who is 190 centimeters? So go back to my graph. Make sure my line is extended. So when I go up from about 190 all the way up to my line of best fit, it will actually meet my line of best fit. And then I'll go over to my y-axis. And it looks like I'm about 12.5, maybe 13. The values, I put that in the wrong spot. And again, I'm looking for shoe size, not height. I'm given the height, I'm looking for the shoe size. So is this interpolation or extrapolation? This is extrapolation because I had to extend the line and I had to go outside the data collected to find the shoe size of someone who is 190 centimeters. Now the values that you may have gotten from your line of best fits may not be 9 and 13, and it all depends on how you drew your line of best fits. It shouldn't be very far off of these two values of 9 and 13 because then your line of best fit is probably not drawn correctly. Okay, so in part F, we're asked which 2 points are outliers. Well, we already discussed this. I circled them as Y and X because they are far away from the line of best fits. Describe the trend in the data in part G. So we will say that there is a linear increasing trend. So that's what you need to include when you're asked about the trends. Say if it's linear or not non-linear, and say if it's increasing or decreasing. So here it is linear and an increasing trend. In part H, we are asked to describe the relationship between the height and the shoe size. So we can say as the height increases, the shoe size increases. In the second question, we are asked to plot the data on the scatter plot below, choosing an appropriate scale and labels. So age comes first, and it is our independent variable. So I'm going to put it along my x-axis. So I will write age. And then I'm going to look, and I see that I have my lowest age at 25 and my highest at 75. So I want to make sure that fits on my x-axis. So I'm going to start off going up in tens, 10, 20, 30, 40, 50, 60, 70. And I only get here. I have double that room left on my axis. So instead of going up by tens, I'm going to go up by fives. So 5 and then 10. So 5 is this first point, but I'm not going to write it because then it will be very squishy, especially with the pen. I'm using the stylus on the iPad. So I'm going to go up every 2 spots to say 10, 20, 30, and keep going up by tens. You could write every 5, 10, 15, as long as you are consistent and you've labeled enough points. So now that we've done our x-axis, let's do our y-axis, our dependent variable, which is earnings. And if you notice, earnings are in thousands. So it is sometimes difficult to think of thousands and how the scale would look. So what I'm going to do is not think about the last 3 digits. I'm just going to think about the first 2. And I see that my lowest number is 22 and my highest looks to be 43. So that's 22,000 and 43,000. So I need to go up to 43. So what I'm going to do is, again, I'm just going to worry about the first 2 digits and go up to 43. So I'm going to try going up in tens, 10, 20, 30, 40. Now that's way too squishy. Actually, I'd have to go up to 50. If I try going up in twos, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, I don't have enough room. So then I'm going to have to go up in fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and that's good. So I still lose some of my space, but this was still the best scale, unless we went up in 3s or 4s, and then it would get a little bit confusing. Try to keep your scale easy. And also, I didn't have to write every 5. Maybe I could have skipped and just wrote 10, 20, 30. Now, again, the numbers are actually in thousands. It's not 5, it's 5,000. It's not 30, it's 30,000. So what I'm going to do, back where it said earnings, I'm going to write earnings in thousands. So that's one way of doing it, or you could have written 5,000, 10,000, 15,000, 20,000, 25,000, and so on. So now I'm going to pause the video while I do my points, and you can do the same thing. You can pause your video and do the points on yours as well. Okay, so I've drawn my points. They're not the best. Again, it's pretty hard to draw it on with the stylus on the iPad. You're not going to be perfect when you plot points, but you want to be as accurate as possible. So let's just take the 40, this point here, 40, age 40 makes 32,000. So at 40, so I have to be right on this line 40, I want to make 32. So it's going to be between 30 and 35. So in the middle of 30 and 35 is 32 and a half. So I don't want to be above this line, which I am a little bit. So that one should be just below the line, which again is really hard for me to do on here. But yeah, you want to be as accurate as possible. You don't want that point to be closer to 35 than 30. So now that I've done this, I'm going to make a line of best fit. And again, this isn't going to be the best line because my points aren't even accurate to begin with, but you want a ruler. You want to split the points, and so try to have as equal meant on either side, and it'd be great if you could go through as many points as possible. So let's answer the follow-up questions. A asks, what does the point 41, 35,000 represent? So it just says that at age 41, someone makes $35,000. B asks for a line of best fit, which we've done. And C asks to use our line to estimate what the earnings would be if you were 50 years old. So here we get a ruler, and at 50 we go up, hit the line of best fits, and then go over. Now you can see here I went a little bit past above my line of best fits. So it should actually be a little bit lower, which cuts 35 and 40 right in the middle, which is 37.5. So that means I would estimate them to earn 37,500. So $37,500. This is interpolation. In part D, we are asked to use the line to estimate at what age you would expect to be earning $40,000. So I'm going to go back up to my line, and at 40,000, so 40 on my grid, go over. So I'm starting at my y-axis this time. Hit your line of best fits, and then come down. So this is 50, this is 55, this is 60. So just past in between 55 and 60, so about 58. And you could have a bit different. Yours could be different depending on your line of best fit. So again, I'm using interpolation here because I was asked to find the age of someone who makes 40,000. 40,000 was within my data collected. So something extrapolation would be if I was asked to find the age of someone who made outside of this, so 60,000 or 90,000, or how much money someone would make if they were 90 years old or 100 years old or 200 years old, which is outside. That's why it's more unreliable when you're doing extrapolation, because this trend will not continue for someone who is 110 and 200 years old and so on, because that's not possible. And even down here, for someone who's young, would you expect a 5-year-old to be making about $12,500? So even on this end, we didn't have any information for a 10 or 20-year-old, and that would be extrapolating as well. And the other point of interest on this graph are these 2 points here, which are a little bit outside the trends. And that makes sense because these people here are 70 and 75 years old. So one possibility could be that these people were making a lot of money on this trend line, but then usually after 65 you're able to retire, so perhaps these people started working part-time, which is why they make less money than the other people on the trend.